Okay, second scenario is that you have one repeated real root alpha, which means the discriminant will be equal to 0, and the general solution to the homogeneous second order differential equation is a plus bx times e to the alpha x. I did work through a little show that algebra on this for you. It's not quite so obvious, but it's not dissimilar, to be honest. So don't worry about this. If you want to work through this yourselves, then do. It's not a bad little algebraic exercise. We know alpha is a root to the auxiliary equation, so we know that a alpha squared plus b alpha plus c is 0. So that's the first sort of thing we know. And we also know that alpha is a repeated root. So quadratic formula, discriminant equals 0, and so alpha is equal to minus b over 2a. So when you work through this, then differentiating once, so I've done product rule here. So I've got, which way around did I do it? So we've got v du dx plus u dv dx to get to y dx, and then differentiating again takes you to here. So I've done product rule again on a plus bx e to the alpha x through there. Then you substitute into this equation here, which gives you this. Then you pull out b e to the alpha x, which takes you to here. Pull out a e to the alpha x, which takes you to here. This bit here equals 0 from here. And then factorising out this bracket, so pulling an x out. This equals 0, so that goes. You're left with 2a alpha plus beta, but we know that alpha is equal to minus b over 2a, and so the whole thing equals 0 as required. So that's kind of the algebra behind the scenes, so to speak. But you really don't need that. But yeah, it's not a bad little exercise to do if you fancy it. So in terms of solving equations, it's actually nice and straightforward. So we've got second derivative d2y dx squared plus 8 lots of the first derivative plus 16y equals 0, and we want to find the general solution. So you find the auxiliary equation. So m squared plus 8m plus 16 equals 0. You could factorise that to give you m plus 4 all squared is 0, so you can see there's a repeated root, or you can put it into your calculator. I was just wondering if it makes it quite clear you've got a repeated root, which it should do. So 1, 8, 16, so it tells you x is minus 4, then it gives you the minimum at x equals minus 4. So you're just, be a bit careful with whether you're picking out one or two roots when you're reading off your calculator display. But yeah, I think you should be okay with that. And so m equals minus 4, and we have a repeated root. Repeated real root even. Or you could actually just use the discriminant, couldn't you? So you could just do b squared minus 4ac equals 0 and not worry about using your calculator. So all sorts of different scenarios there. I'm completely overthinking it. But alternatively, when you're solving those, you could do that. I'm tempted just to whack them into a calculator personally. And so the solution, y is equal to a plus bx e to the minus 4x. Job done. So if you could just do a few of those, and then we'll move on to the complex roots and see what happens with those.